Good morning. It's a snowy morning here in Missouri in February, and this short video will be for learning how to do a normal probability plot using CALC 84. And as I've said in many of the other videos, this is quite similar to doing the same procedure using a TI 84. And so let's jump right into it. This will be very short. Okay, so I have my CALC 84 open. This one is on a Chromebook, so it will look somewhat different if you're using a phone to do this. I've already entered data in. Let me show it to you. Stat, edit. I have a list, and I'll just scroll down to the bottom just to give you a sense for how much data is there. If I can get there we go. So this is actually a set of data that I was using with one of my tutorees, a college student, taking statistics. So 30 items of data. Now I've sorted the data. Originally it was not sorted. And if you're not sure how to sort, let me just show you that real quick. First of all, you want to leave the window in which your data is located. Choose stat. And then you have two choices. You can sort in ascending, in other words, from lowest to greatest, or you can sort it in descending, greatest to least. Okay, so back to our data. Well, really, okay, so I've shown you the data. We don't need to look at that anymore. Let's talk about how to get a normal probability plot. And then I'll talk a little bit about what a normal probability plot is. The normal probability plot is the one that is furthest over to the right. It asks you which of the two axes you wish to have as your data axis. Typically, you're going to have the x-axis be your data axis, and you will have L1 typically as the list in which your data is located, but you might have it in a different one. Choose graph. Now, when you first do the graph on these, you're typically not going to see your values. And so to get to where you can see them, choose zoom stat. And then at this point, we do in fact see the data on the coordinate axis. When you see that, what you're seeing is on the x-axis, you're seeing a list of the values. That's the x-coordinate. The y-coordinate reflects what that data point is in terms of a z-score. So in other words, if you have a point, let's say I'm looking at the point where the x-coordinate is approximately 550, and it looks to me that the y-coordinate there is approximately 1. And so what that would tell me is that the value of 550, for whatever this data is, I don't even remember, is 1 standard deviation above the mean. Okay, and so if you wanted to look on here and get an indication of what the average value is, you can see that about 450 is right on the x-axis, but then again, so is about 370. It's a little bit below, but anyway, 450 is about right on the x-axis and is therefore approximately the mean for this data. We could calculate it real quick and see what the mean actually is, but it'd be something close to that. Now, if I was assessing this data for normality, I would find it troubling that this could be a normal distribution, and here's why. Typically what we want to see is well, let me just say this. I'm going to confine it. This isn't a lesson about assessing for normality, so I'm not going to go into all the details of it. But what we don't want to see is we don't want to see a curved pattern to the data similar to what we see here. There's definitely a curved pattern to the data, which would be an indication that our data is not likely to follow the normal distribution. So very easy to get a normal probability plot on there. Enter the data in to L1 or L2 or wherever you want. Go to stat plot, choose the plot that I showed you. Use zoom stat so that you can see the data, and you've got yourself a normal probability plot, and all you have to do is learn how to look at it and know whether or not it gives you some indication that the data is normal. This is a huge AP concept. It'll show up on almost every AP exam. I'm not saying it's like 25% of the test, but it is something that if you're taking the AP exam, you should know about.